This Zoom session is being brought to you by the Fractal Horizon. All right. Okay, for today, we finally get trigonometry. I tell you, it takes, how long has it been? 2 or 3 weeks, something like that? Finally, we get to the actual content of the course, which is trigonometry. Here we go. We're going to define the trigonometric functions, and there's 3 ways we're going to define them: on a circle, in the plane, and with right triangles. Historically, this is the oldest, but these first 2 are most flexible, I suppose. This one is actually, in some ways, the simplest, but it's also the most modern. That often happens. Okay, so we start with the unit circle. X squared plus y squared equals 1. And we make a ray at an angle of theta from the positive x-axis, and it meets the circle at the point x by y. The x-coordinate is called the cosine, cos of theta. The y-coordinate is called the sine of theta. Sine is spelled sin of theta is how it's written mathematically. Then there are also some other trig functions. The tangent of theta, which is y over x. The cotangent is x over y. The secant is 1 over x, and the cosecant is 1 over y. When we get to the third definition, the reasons for these will become clear. Okay, a couple of things. X squared plus y squared equals 1. X is cosine, y is sine, so therefore cosine squared plus sine squared equals 1. That's known as the Pythagorean identity. Also, these ratios, x over y, 1 over x, 1 over x, 1 over y, connect to these, cosine and sine, fairly clearly to say that tangent is sine divided by cosine, cotangent is cosine divided by sine, secant is 1 over cosine, and cosecant is 1 over sine. This means that these 4 functions sometimes run into trouble when cosine or sine equals 0. But cosine and sine are never infinite, so in some sense they're the best of them. All right, now, this is defining trig functions on the unit circle. Similar way, we can define it on the plane. So here we have an angle theta from the positive x-axis, a ray of length r this time, to the point x by y. Now, r by Pythagoras is the square root of x squared plus y squared. And cosine, well, when r is 1, we can get these definitions. Cosine is x over r, sine is y over r. Then the tangent through cotangent are the same ratios as before. Y over x, I'll say, okay, r over x, r over y, and x over y. So these ratios still apply. Tangent is sine over cosine, cotangent is cosine over sine, secant is 1 over cosine, and cosecant is 1 over sine. So that's these connect to that. And if this were on a unit circle, the definition of cosine and sine would, of course, would be the same as these. And if you draw a unit circle around here, then the point on the unit circle would be x over r by y over r, as befits. Now, this is the oldest one, going back to before we had taken negative numbers seriously, way back when trigonometry was about right triangles. So here's a right triangle. Here's an angle theta. Here's opposite theta. Here's adjacent to theta, and here's the hypotenuse. Now, okay, adjacent corresponds to x, opposite corresponds to y, hypotenuse corresponds to r. And so if you use just change these over to here, cosine is adjacent over hypotenuse, x over r. Sine is opposite over hypotenuse, y over r. Tangent is opposite over adjacent, y over x. Cotangent is adjacent over opposite, x over y. Secant is hypotenuse over adjacent, r over x, and therefore 1 over cosine. Cosecant is hypotenuse over opposite, r over y, and therefore r over y, and therefore 1 over sine. Okay. Now, if you have a right angle triangle, and this is angle theta, then this angle phi and theta are complement. They add up to these 2 plus 90 degrees add up to 180. Therefore, theta plus phi adds up to 90, and therefore phi is 90 degrees minus theta, the complement of theta. Now, if you look back up here, opposite theta is adjacent to phi, adjacent to theta is opposite to phi, and hypotenuse is hypotenuse to both. So therefore that swaps cosine and sine. Cosine theta is sine phi, sine theta is cosine phi. And then if you go back to all the other definitions, tangent swaps with cotangent. Tangent theta is cotangent phi, cotangent theta is tangent phi. Secant and cosecant also swap. Sec theta is cosec phi, cosec theta is secant phi. In general, the trig at theta equals the cotrig at 90 degrees minus theta. And equivalently, the cotrig at theta equals the trig at 90 degrees minus theta. So cotrig is trig of the complement. Now there's some special angles whose trig functions are relatively easy to visualize, and you do it easily by drawing some simple triangles. Here is the isosceles right triangle with 90 degrees at this corner, 45 degrees at the other two corners, sides 1 and 1, and by Pythagoras, the hypotenuse is root 2. Then you can read off the trig functions. Cosine is adjacent over hypotenuse, 1 over root 2, which when you rationalize becomes root 2 over 2. Sine of 45 is opposite over hypotenuse, 1 over root 2, also root 2 over 2. Tangent is opposite over adjacent, 1 over 1, which is 1. And secant of 45 is 1 over cosine, and therefore root 2. Cosecant of 45 degrees is 1 over sine of 45 degrees, therefore again root 2. And cotangent is adjacent over opposite, which is 1 over 1, or 1. So these ratios show up. And that can be, you can read them, you can remember them just by drawing this triangle. There's also the equilateral triangle. Start with an equilateral triangle, 3 equal sides, make them length 2 for convenience sake. Their angles at the corners will also be equal. They add up to 180 degrees. 3 angles add up to 180 degrees. Each one is 60 degrees. You drop this perpendicular, splitting this side into 1 and 1, and this is a right angle. And but you can figure from Pythagoras that this altitude is root 3. 1 squared plus root 3 squared is 1 plus 3 is 4, which is 2 squared. So we have this, the 30-60 triangle. This angle is 30 degrees. It's half of 60. So this is 30, this is 60, this is 90 degrees. Short side is 1, longest side is 2, medium side is root 3. And we can read off cosines and sines for 60 degrees and 30 degrees. Cosine of 60 is adjacent over hypotenuse, 1 over 2. Sine of 60 degrees is opposite over hypotenuse, root 3 over 2. Now, for cosine and sine of 30 degrees, cosine, root 3 is its adjacent to it. So cosine is root 3 over 2. Sine is opposite 30 degrees over 2, 1 over 2. Okay, tangent of 60 degrees is opposite over adjacent, root 3. Similarly with cotangent of 30 degrees is adjacent over opposite, root 3. Cotangent of 60 degrees, well, it's always the reciprocal of tangent, so this would be 1 over root 3, root 3 over 3. Similar with tan of 30 degrees, it would be the same as cotangent 60, root 3 over 3. Secant of 60 is hypotenuse over adjacent, therefore 2. And for 30 degrees, it's hypotenuse over opposite. Cosecant is 2. And cosecant of 60 degrees is hypotenuse over adjacent, 2 over root 3, which is 2 root 3 divided by 3, which is also similarly secant of 30 degrees. So trig of 60 degrees equals cotrig of 30. Cotrig of 60 degrees equals trig of 30. A complementary problem. Now later, we'll talk about the 15, 45, 90 triangle. And it has sides like this. Hypotenuse 4, root 6 plus root 2, opposite the 75, root 6 minus root 2, opposite the 15. And you can read out cosines and sines and so on from this. Like I said, I'll be getting this later. So we have some examples. What is the sine of 11 pi over 2? Now, pi is 1/2 of a turn. So 180 turn. 1, 2, 3. Oh, I'm sorry. Oh. Pi is what am I saying? Pi is a 180 degrees. Pi over 2 is 90 degrees. So here's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 pi over 2, 11 quarter turns. Landing at 0 by -1, and the sign is the y coordinate. So it's sine 11 pi over 2 is -1. Cosine of 11 pi over 2 is 0. Here they ask for sine 90 degrees minus 3 tan 180 degrees. Okay, for sine 90 degrees, we turn a quarter to 0 by 1. So sine is the y coordinate 1. 4 times 1 minus 3 times tangent 180. We go 180 degrees to -1 by 0. Tangent is y over x, 0 over -1. This is a 0. This cancels out. 4 times 1, leaving 4 times 1 is a 4, and that's that. Here they ask for all 6 trig functions of 2 pi over 3 radians. Well, if you convert 180 degrees for every pi radians, you get 2/3 of 180, or 120 degrees. 60 degrees, 120 degrees, 180 degrees. And this is a 30, 60, 90 triangle. Go out. Let's go out 2. So it's back 1 and up √3. And so this is -1 by 3. And this is a radius of 2. And so we can read off all the trig functions. Cosine is x over r minus 1/2. Sine is y over r √3/2. And tangent is y over x. √3 over -1 is minus √3. And these 3 are reciprocals. Secant is 1 over cosine. Reciprocal of -1/2 is -2. Cosecant is reciprocal of sine. That's 2 over √3. And you can reduce that, but that's not necessary. And cotangent is reciprocal of tangent, -1 over √3. Here we ask for all 6 trig functions of 210 degrees. 210 degrees is 30 degrees past 180. So you have a 30-degree angle here. And let's see, minus √3, down 1, out √2, out 2. And so cosine is minus √3 over 2. And secant is a reciprocal, -2 over √3, or -2 √3 over 3. Sine is opposite over hypotenuse, -1 over 2. Cosecant is reciprocal, -2. Tangent is opposite over adjacent, -1 over √3, or 1 over √3, or √3 over 3. Cotangent is the reciprocal, is √3. Then the book asks for basically asks you to go to your calculator. Sine of 28 degrees. Let's see. To find this out, first you need to make sure that, let's clear this out. First, you need to make sure that it's in degree mode. So I hit mode button, that's in degrees. And there's a sine button of 28. Hit enter, 0.469471568. Calculators give far too many figures accuracy. Then here's this other one is tangent pi over 10. When they don't denote a degrees, this is assumed to be in radian mode. So I hit mode button here, the mode button, toggle it down to make it radian mode. I hope you can see any of this. All right, it's in radian mode now. Quit and hit tangent of pi. Use the pi button on the calculator. Over 10 gives you approximately 0.3249196 and so on. So it's on the calculator. Used to be they'd have trig classes, trig textbooks would have a trig table in the back. That's now obsolete. Well, anyhow, there's that. I believe we are done for now. Let's take a look. And recording.